Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching, I request you to share the videos with your friends. If you does not like my videos, I request you to share the videos with your enemies. Okay? So what I want to say is that don't stop sharing my videos. If you like them, share with your friends. If you does not like, share with your enemies. Okay? So in this video, I want to discuss converting regular expressions to a finite automata. How we will do, we will discuss now. Now, if you see that the regular expression is phi, it is given. If it is phi is nothing but what? It does not consist of any strings. So, the long ways is an empty long ways. If it is an empty long ways, how can I write? I will have an initial state q naught and that's all. There will be no final state, nothing, because it should not accept any strings. Phi is an empty long ways, it does not consist of any strings. So if you want to construct a finite automata which does not accept any strings, then your initial state will be there, that's all. Okay, there will be no final state, nothing. Now you want to construct the finite automata for regular expression epsilon. If it is epsilon means what? You will have an epsilon which consists of only one string. If you have a one string which is an epsilon, what I have to do? My initial state only should accept as a final state. We have discussed enough examples why the initial state should accept as a final state. Okay, it should act as a final state also, so that it will accept the epsilon symbol. Okay, now I want to discuss about the 0. Okay, we have a 0. How to do it? I will have an initial state q naught. From q naught on 0, I have to reach a final state. So it will accept the string called 0, because see, it is a finite long way. So if we have a finite long ways, we can easily construct the finite automata. So from an initial state on taking 0, you are reaching to the final state. So it is correct. Now we will discuss about 0 or 1, or I can read it as 0 union 1. Okay, for space constraint I am doing it. So 0 union 1, we will discuss how it is. So what is the meaning? Either from the initial state q naught on 0 I should reach to the final state, on 1 also I should reach to the final state. So it will accept the string either 0 or 1. So I have written 0 or 1 like this. So on q naught, from initial state q naught, on taking the alphabet 0, I am reaching to the final state. Similarly, from q naught on 1, I am reaching to the final state q1. So it is accepted. Now instead of that one, we can draw like this also. 0, 1, q1 final state. Both are same only. Okay, either you can write double edges or with single edge you can write 0, 1. Meaning is that either 0 it should accept or 1 it should reach to the final state. Okay, now we will discuss the next example. 0 concatenation with 1. How to do the 0 concatenation with 1 we will discuss now. Meaning is what? From the initial state on 0 it should reach to some intermediate state. From intermediate state on 1 you should accept. So you will see we have an initial state q naught. On 0 I am reaching to some state. From that state on 1 I am reaching to the final state. So this will act as a finite automata for the given regular expression 0 concatenation is 1. So from initial state q naught on 0 you are coming to q1. From q1 on alphabet 1 you are reaching to the final state. Whether it is an NFA or DFA, it is obviously NFA, because q naught on 1 we don't have a moves. From q1 on 0 we don't have moves. q2 on 0 and 1 we don't have moves. As we discussed earlier, constructing NFA is quite easy as compared to the DFA. Okay. Now we will discuss the next one. 1 clean plus. What is meant by 1 clean plus? What are the strings are possible? 1, single 1, length 2, length 3, so on. Only difference between the clean star and clean plus is that you will not have epsilon in the clean plus. Okay, means zero length strings it does not allow, only length 1, length 2, length 3, so on. As it is a finite language or infinite language, as it consists of infinite number of strings, I can say that it is an infinite language. So if it is an infinite language, we will check whether we can construct a finite automata for it or not. Okay, so from a q naught on 1 I am reaching to a final state. Okay, then how many ones it comes I will accept here. So first thing is that take the smallest string possible in this given language, 1. So from q naught on 1 you should reach to the final state. Now from there, either once you see a single one, it is the smallest. If it is two ones, you should accept. So from q1 on seeing another one, I will be here itself. Okay, are you able to understand? Then if it is three ones, if you want to see, you can see it. Okay, from q naught initial state on 1 I am reaching to the q1. Once I reach q1 on 1, I am again in the q1 only. q1 on 1 again in q1. q1 on 1 again you are reaching to the state q1, because you are traversing there only. From q naught on 1 you are coming to q1. How many ones comes, you will be in the state q1. If you see that the initial state is q naught. Okay, the initial state is q naught. From q naught on taking the string 1 1 1 1, I am reaching to a state called q1, which is acts as a final state. So what I can say, from initial state, from taking the string, if I reach to any one of the final state, I can say that the string is accepted by the finite automata. So I can say that this is the finite automata for the regular expression 1 clean plus. So now we will discuss another set of examples. We'll try to increase the little bit complexity. Now if you see that one clean closure is there. What is meant by one clean closure? One clean closure is you should accept zero length strings. Zero length strings means epsilon, length 1, length 2, length 3, so on. So it consists of infinite number of strings. So I can say that this is an infinite language. If it is an infinite language, we'll check it whether we can construct the finite automata or not. As the smallest string is epsilon, so your initial state should accept as a final state. Take the smallest string in it. Smallest string is epsilon because it is zero length. Don't think that both epsilon and 1 are same. Epsilon is zero length, 1 is length 1 string. Okay, so if you have the smallest string epsilon, your initial state should act as a final state. Now if it is 0 ones, okay, single one also I will accept here. 2 ones or more than 1 1, I can still in the same state. I no need to go for another separate state. Okay, so this is the finite automata for regular expression 1 clean closure. If you want to verify, you can verify. Epsilon it will accept, single one it will accept, 2 ones it will accept, any number of ones it will accept. Okay, so now we will discuss the next one. Okay, 0 or 1 epsilon clean closure. Okay, 0 or 1, so it can be 0 or it can be 1. So now we will discuss few examples. If it is 0 length, so 0 or 1 of power 0 union 1 power 0. What is the meaning? Length 0. Length 0 means you will get epsilon. Length 1 means 0 or 1 whole power 1. So you will get either 0 or you will get 1. If it is 0 union 1 power 2 means it is length 2 strings. Length 2 strings means 0 0 0 1 1 0 1 1. If you get a doubt how I got it, we already discussed. Okay, 0 union 1 concatenation with 0 union 1. Then what I can do? 0 concatenated with 0, I will get 0 0 string. 0 concatenated with 1, so I will get 0 1. 1 concatenated with 0, I will get 1 0. 1 concatenated with 1, I will get 1 1. So I will get all the strings whose length is 2. So on I will get, means length 0, length 1, length 2, length 3, so on I will get infinite number of strings. If it is infinite number of strings, what can I say? It is an infinite long ways. If it is an infinite long ways, now we will try to construct the finite automata for it. Now take the smallest string is epsilon. Whenever you have an epsilon, your initial state should act as a final state. Okay. Now a single zero you should accept, two zeros also you should accept, three number of zeros also you should accept, meaning is that any number of zeros you should accept. Now if you see that any number of ones also you should accept, 1, 2 ones, 3 ones, like that you should accept. You can write like this, or as I discussed earlier, you can take the initial state as a final state. On 0 comma 1 you can reach to the q naught. Okay, what is meant by 0 comma q naught? Either on 0 you will reach q naught, or 1 you can reach. See, you can write like this, on 0 you will be in the q naught, or 1 in the q naught. If you want to have a single loop, then 0 comma 1, meaning is that either on 0 or on 1 you can do this transaction. Okay, so I hope it is clear. This is very simple one. Okay, but anyway, as you are beginners, I am discussing for you. If you already know these concepts, you try to pass the you try to do the videos by you try to solve these questions by pausing the video. Okay, now we will discuss the next one. This is done. Now we will discuss the next question. 0 clean closure, 1 clean closure. So how I can do? What is the smallest string possible? If it is both are 0, length 0, I can take it as epsilon. And another one is that I can get a single 0, I can get single 1, 0, 0, 1, 1, all these things. Okay. Now what is the difference between these two? This one and this one, if you see that, in this one, all the zeros should be finished, then once a 1 you got, then after 1 you should not get any zeros, but that is possible here. The strings, if you see that 1, 0 is not possible with this regular expression. However, it is possible with this one. So don't get confused, these two are different. Okay. Now we will see how can we solve it. Now if you see that we have epsilon. So if you have epsilon, your initial state should act as a final state. Okay. Now the smallest string I will take it as 1. So on 1 I should reach to the final state, because 1 also I should accept it. So any number of zeros I will be in q naught. Once I see a 1, any number of ones it will be accepted. Now we will see whether it is correct or not. Epsilon, I can reach to the initial state q naught, epsilon will be accepted. Single 0 will be accepted. Yes, single 0 will be accepted. 1 it will accept. 0, 0 it will accept. 2 ones, from q naught on 1 I can come to q1. q1 on another one I can be in the q1, so it will be accepted. Now you see whether 1, 0 will be accepted or not. Whether 1, 0 belongs to this long ways? No, it does not belongs to this long ways. So I can say that my finite automata should not accept. Q naught on 1 I am reaching to q1. Okay. Q naught on 1 I am reaching to the state called q1. From q1 on 0 there is no move. So it is going to a dead configuration. So I can say that the string does not accept by the finite automata. Or if you get confused by doing this one, you can solve in another way also. It is simple way I will discuss. Okay. So you should accept as 0 number of epsilon you should accept. So take the initial state as a final state. Accept any number of zeros. Then go on epsilon. Any number of ones you accept. Or you can leave your initial state without final state also. This is also possible. We will see how can be done. If I want to accept epsilon, epsilon is the smallest string possible in this long ways. So from q naught on epsilon I am reaching to a final state. So here my q naught is not a final state, q naught is just initial state. Okay. So Q naught on epsilon, I am reaching to Q1. So epsilon is accepted. If I want to accept 0, whether 0 will be accepted or not, lot of people will get confused. 0 will be still accepted. From Q naught on 0, I will go to Q naught. I can add epsilon. Okay, 0 concatenated with epsilon is what? 0. So to the 0 I can add an epsilon. So Q naught and epsilon, I am reaching to a state called Q1, which is a final state. So I can say that 0 also accepted. If I want to accept a 1, then what I will do? From Q naught on epsilon, I will come to Q1. Q1 on 1, I will reach to the final state Q1. So I can say that it is accepted. Are you able to understand? So Q naught on 0, you will go to the Q naught itself. Q naught on epsilon, you will come to Q1. Q1 on any number of ones, you be there in the Q1 itself. So even this is also, this is epsilon NFA and this is NFA. That is only the difference, but both are finite automatas only. So if you can understand this way, or if you can construct like this, it is okay. If you cannot do like this, you can use the epsilon moves also. Epsilon moves are very easy. Compared to NFA, DFA, epsilon NFA construction is quite easy. Is it clear? Now we will solve the next question. What is the next one? 0, 1, 0, 1 clean closure. Is it clear? So what I will do? It can accept epsilon. It will accept 0, 1. It will accept 0, 1, 0, 1. It will accept 0, 1, 0, 1, 0, 1. Am I right or wrong? If you want to verify, you can verify. These are the set of strings possible. As it consists of infinite number of strings, you will get an infinite long ways. If you get an infinite long ways, we will check it whether we can construct the finite automata or not. If it is a finite long ways, we can easily construct the finite automata. If it is infinite long ways, we have a doubt. We will see whether we can construct it or not. Lot of people will do like this. As it is in epsilon, your initial state is acts as a final state. It is okay. They will keep 0, 1 here. But whether 0, 1 is correct, 0, 1 is not correct, because you have alphabets 0, 1. Is it clear? It is not like I have an alphabet called 0, 1. The alphabets are 0, 1. So you have an alphabet 0, you have an alphabet 1. So remember one thing, whenever you have a transition, you should go on a 1 alphabet only. But 0, 1 is not correct. So how can I do? Now see how I will do. Epsilon should be accepted. Am I right? So on 0, I should not accept. After 0, if I see a 1, I should accept. That's simple. So epsilon will be accepted. 0, it is not accepting. 1, it is accepting. So 0, 1, it is accepting. 0, 1, 0, 1, again 0 and 1. If you want to verify, you can verify. If you want to see, I will discuss also. Q naught on 0, you will come to Q1. Q1 on 1, you are reaching to a state called Q naught. Q naught on 0, you are going to Q1. Q1 on 1, you are reaching to the Q naught, which is a final state. So I can say that the string is accepted. So even we are done with this one also. Okay. All the question, now we have left the last question. We will solve it now. Now I need to solve, or I need to find the finite automata for the regular expression 0 clean closure concatenated with 1. How we will do it, we will see. What is the smallest string is possible? Smallest string is 1. If the 0 number of zeros comes also, you have a 1. How it is? 0 power 0, 1. 0 power 0 is epsilon, concatenated with 1 is, you will get 1. Is it clear? So the smallest string is 1. The next you will get 0, 1. You may get any number of zeros and 1. So all these things. So how you can do? As you does not have epsilon, your initial state need not to have a act as a final state. So Q naught on 1, I will go to Q1, which will act as a final state. Please listen. Take the smallest string. So 1. So Q naught on 1, you should reach to the final state. Now any number of zeros it can come. If it is a single 0, 1, you should accept. More than 1 0 and then 1, you should accept. So any number of zeros, I will be there in the Q naught, okay, and then I will reach to the 1. So it is accept the all the strings which are in the form of 0 clean closure 1. If you want to verify, you can verify 0 0 1. Q naught on 0, I am in Q naught. Q naught on 0, again I am in Q naught. Now once I see a 1, Q naught on 1, I will reach the final state. It is accepted. Okay, so in this video we have taken few regular expressions and we have constructed the finite automata. If you have any doubts how I have constructed, you can solve it, or if you have any doubts, you please ask the doubts in the comment section. I will clear your doubts within less than 24 hours. If you have any complex questions, you please ask me. I will solve and forward to you. Thank you so much.